Astronomers have observed what they believe is the formation of the universe 13.6 billion years ago, when the earliest stars were just starting to shine. The astronomers say their observations may also have measured mysterious dark matter from that time. The observations, however, were not in visible light, but in weak radio signals from deep space. An antenna in the Australian desert captured the radio signals. This receiver is a little bigger than a large television and costs less than $5 million. Because it records radio signals and not visible light, the antenna can detect objects that are more distant than the famous Hubble Space Telescope. Judd Bowman of Arizona State University helped to write the report, which was published in the journal Nature. He says the signals came from the very first objects in the universe, as it was coming out of darkness 180 million years after the Big Bang. Many scientists believe the universe began with a huge explosion they call the Big Bang. Stars and galaxies began to appear as the fireball of hydrogen and helium gas expanded and cooled. Richard Ellis is an astronomer who works at University College London. He says finding the signal from the first stars is more important than the Big Bang. Ellis said, "We are made of star stuff. By identifying the first signs of stars, we are seeing the beginnings of our existence," he said. Ellis was not involved in the project. The astronomers studied the signals closely. They showed unexpectedly low temperatures and an unusually strong wave. When the astronomers tried to find out why, the best explanation they could find was that dark matter was present. If true, their observations would be the first confirmation of dark matter that does not depend on its gravitational effect. For many years, scientists have been looking for dark matter, which is believed to make up a large part of the universe's mass. If confirmed, this discovery deserves 2 Nobel Prizes, for both capturing the signal of the first stars and for possible dark matter confirmation, said Avi Loeb of Harvard University. He added that independent tests are needed to confirm the findings. Loeb, an astronomer, was not part of the study. Bowman agreed independent tests are needed. He told the AP his team spent 2 years confirming their findings. "It's a time of the universe we really don't know anything about," Bowman said. He said the discovery is like the first sentence in the early story of the history of the universe. However, the findings are nothing that astronomers could actually see. In fact, it is all based on differences in the wavelengths of radio signals. Scientists think the early universe was dark and cold, filled only with 2 gases, hydrogen and helium. Once stars formed, they released ultraviolet light into the dark areas between them. That ultraviolet light changed the energy signature of hydrogen atoms, Bowman said. Astronomers looked at a specific wavelength. If there were stars and ultraviolet light, they would see one signature. If there were no stars, they would see another. They saw a clear, but very weak, signal, providing evidence of stars, probably many of them, Bowman said. Finding that first signal was not easy, because the Milky Way alone produces radio wave noise 10,000 times louder, said Peter Kurzynski of the United States National Science Foundation. The government agency provided financial help for the study. Because the high end of the radio frequency is similar to that of FM radio signals, the astronomers had to go to Australia to escape interference. That was where they put up their antennas. They worked to confirm what they found, in part by testing it against signals produced in a laboratory. Bowman said it all showed that what they had found was evidence of the existence of the first stars. Scientists know little about these early stars. They were probably hotter and simpler than modern stars, Ellis and Bowman said. But now that astronomers know where and how to look, others will confirm this and learn more, Bowman noted. The research has yet to establish exactly when these stars turned on, except that they were shining 180 million years after the Big Bang. Scientists had come up with many different time periods for when the first stars began to shine, and 180 million years would be about right under the current theory, said Ellis. Reynan Barkana is an astrophysicist who has written about the findings. He said when the astronomers studied their results, they found that the hydrogen between stars was even colder than the coldest we thought possible. The researchers expected temperatures to be 10 degrees above absolute zero, but they were 5 degrees above absolute zero, or minus 268 degrees Celsius. Barkana and others believe this may be caused by dark matter. If confirmed, the discovery could add a new important part to scientists' thinking about the early universe.